Hello everyone, welcome to this technical session about Raincode IMSql, where we're going to discuss how we can migrate IMS workloads from the mainframe into Azure. We're also going to discuss Azure SQL with its high volume transactional capabilities and explain how that can help us in this endeavor. My name is Markus Lindström. I'm Chief Technical Officer at Raincode. I've worked pretty extensively on making the Raincode product line work with the Azure platform. And speaking of Azure, we have two lovely guests from Microsoft with us here today. So first of all, we have Ulrich Homman, who's Corporate Vice President and a distinguished architect in the cloud and AI technologies. We will also discuss with Assad who's with us here, who's Vice President and General Manager for the SQL products and services. So, welcome, Uli. We've had a pretty long relationship between Raincode and Microsoft for a pretty long time now. How would you characterize this relationship?
Well, first of all, thank you for hosting us, and it's a pleasure to be with you again and talking about this awesome capability that you have built. Our relationship has been awesome for a long time, but it's gotten even more important, I think, over the last years, because cloud has reimagined how mission-critical applications are actually being operated and run. Currently, most of these are mainframe workloads, and it's very important to our customers to look at hybrid cloud architectures using Azure Arc and host integration server type products, along with the right tools to implement their modernization strategy. Raincode has been an important partner in this area, helping customers of Microsoft and Raincode with every aspect of their migration journey from mainframes. So the characterization, I would say, is a critical partner on the journey of modernization for our customers, utilizing the Microsoft product portfolio, not just cloud, but also hybrid capabilities and modern approaches to DevOps, operations, and so forth.
So you often talk with C-level executives at customers. How important is data modernization as part of the mainframe migration journey?
Well, other than lift and shift mainframe projects, which are existing but fairly rare, all other modernization initiatives are with a data-first mindset. In fact, application and middleware strategies are heavily dependent on data tier modernization.
Yeah, I agree. Data is indeed front and center for our customers. So what would be your guidance to customers, system integrators, and partners with how to kickstart a mainframe modernization process?
Well, mainframe applications and data migrations continue to be a sore point, something that could not be credibly migrated at scale due to risk, complexity, and so forth. The assumption is not longer true. Microsoft has been investing heavily in helping customers migrate this critical tier 1 mainframe workloads to Azure. For example, Azure has dedicated engineering and mainframe specialists who provide subject matter expertise, support across different migration phases, along with custom assets creation to bridge current product gaps and post-migration activities like environment cutover, performance optimization, operation optimization, and so forth. And partners like Raincode are helping our customers with comprehensive solutions. With that said, as you're aware, IMS is a very different workload type. From a technical standpoint, how does IMS workload modernization differ from typical COBOL DB2 KICS modernization, Markus?
Yeah, so there's the obvious. DB2 is a relational database, and as we know, Azure offers plenty of solutions in that regard, including SQL Server and Azure SQL. When it comes to COBOL, that's pretty much covered as well. So Raincode and others already provide migration solutions while keeping identical functionality in that regard. But when it comes to IMS, things are a bit more tricky because IMS is not a relational database, as we know. It's in fact based on a hierarchical model, which actually predates the relational databases we know today. And beyond that, IMS also has a very strong focus on performance. It's really performance sensitive, which means that when we do a migration, we really have to take that into account, and means that we will have to really take care about latency, contention, volume, etc. So the thing with IMS is that there's not a one-size-fits-all solution there.
Well, as you rightly pointed out, IMS is a complex technology, and migrating from IMS is a huge issue for our customers today. How does IMS SQL help modernize IMS workloads on Azure?
So Raincode IMSql is a complete rehosting solution for IMS workloads on SQL Server and Azure SQL. And it can be used to cover both IMSDB and IMSDC workloads. So it's not only a database processing system, it's also a transaction management system. So it allows us to cover both sides of the IMS coin, so to speak. And we designed IMSql from the ground up. So it wasn't really tacked on another product as an afterthought. We really designed it this way. And this allows us to provide accurate IMS emulation while also enabling strong horizontal scalability on the cloud.
Well, I remember the first time Darius, your CEO, talked to me about IMSql, and I was like, whoa, this is a real game changer. This is very, very unique and differentiated. So super appreciative. So what does this mean from a customer perspective? What do they need to consider, and how can they do an assessment of their IMS workload for modernization?
So we provide customers with a complete assessment of their asset portfolio. We cover COBOL and PL1 sources, IMS assets such as MFSs and DBDs, JCL batch files, basically everything. The idea is to really provide a complete picture of the upcoming migration process. We want to identify possible challenges and assess general suitability of the migration as well. And the idea behind IMSql is really to be able to tackle the IMS problem as a topic in its own right. We didn't want it to be like a sideline on a database track or whatnot. We really wanted IMS to be a topic in its own right that needs to be handled with specific solutions. So, Assad, thanks for joining us as well. So as we mentioned, you're the general manager of SQL products and services, and we would love to get your perspective on using Azure SQL and SQL Server technologies to implement a solution such as IMSql.
Hello, Markus, and glad to be here. First of all, thanks for trusting in SQL Server and Azure SQL capabilities and investing in Microsoft partnership. To answer your question, on top of my mind, IMSql and SQL strengths lie on engine parity between SQL Server and IMSDB, the SQL service broker replacing the IMS transaction management process, the data type and built-in function parity to ensure better performance, efficiency in the initial data load using the SQL bulk copy, also known as the BCP, for aggressive cutover requirements with online migration needs, and lastly, ability for customers to adopt SQL on-prem or SQL Azure, or both.
Yeah, and to us, it all makes sense. So IMSql relies on SQL Server for the database processing part, where it's the obvious choice. But we also extensively rely on the service broker technology provided by SQL Server to handle the transaction processing aspect.
Yes, and this is where SQL as a product with wide-ranging functionalities make it ideal platform for ISV solution. Since IMSql depends entirely different SQL Server functionality to handle the transactions versus the database management, they can be deployed independent of each other. Customer can have use cases where IMSDB is deployed together with CICS for the transactional side. So, Markus, many of our audiences might ask, how does a relational database like SQL Server be utilized for the storage of IMSDB data, which is hierarchical in nature? And what made Raincode choose SQL and the relational model?
Yeah, there are many benefits to using a relational database for persistence. So relational databases are obviously cloud-friendly, which a file system is definitely not. As we know, relational databases on the cloud will provide various features such as online backup facilities, redundancy, etc. But it's not only about storage, because IMSql also aims to provide top-notch performance. And for that reason, what we are trying to do as much as possible is to offload complex processing to stored procedures within the database. We could have done it using dynamic SQL statements, but as we know, that performance would really take a hit if we did that. So we really try to push as much as possible to the database, and that's another added bonus.
No, I agree. And SQL stored procs are a very effective way to enhance the performance. I'm curious, how does IMSql handle queries that are dynamic in nature and cannot be compiled into stored procs?
Yeah, so IMS supports arbitrary conditions using what we call segment search arguments, or SSAs. Those are dynamic by nature, so we can't implement them by any other means than using dynamic SQL statements, which we know are a bit slower. However, it's important to note that the most common and the most computationally expensive operations done by IMS can in fact be implemented using statically generated stored procedures, and that's really going to make a big difference in performance.
Makes sense, makes sense. So Markus, I understand that these queries are also efficient since there is no data conversion needed, but why store the data in binary format? Wouldn't you be better off by mapping the data to SQL columns?
Yeah, in an ideal world, you'd be right. If we had, I would say, infinite time and resources, we would obviously be able to just take the IMS DB data and put it into neatly structured relational tables. But in practice, data is either often corrupted or unsuitable for trivial mapping into relational databases. And this can be due, for example, due to COBOL redefines, which is another mess and a half. And more importantly, doing that really gives you a gigantic uncertainty on the migration process. And this is because of the fact that to do that, well, if you want to take that naive approach, you actually have to validate the whole data migration before being able to move on to anything else. So you have to make sure that the data is clean and works with all the application, etc. You would also have to do this on production databases, which may be difficult due to their size and because of various security policies, which may prevent you from actually manipulating that data as easily as you would want. So we take a different approach. So IMSql, instead of trying to translate it neatly into these relational tables, really takes the IMS DB data in binary form and we pull it into SQL Server as it is. So this makes the migration of the data quite easy because we just unload it from the mainframe in binary form and we just load it into SQL Server directly. And as far as the initial data loading goes, performance is no longer an issue either because we use SQL Server's own BCP utility for really super fast bulk insertion. So the initial data load is not a concern anymore at this point either.
No, makes sense. And this is a distinctive way to store and retrieve data and highlights the different ways SQL can be used. For customers wondering how to utilize this data through other Azure services, there are read-write SQL views on top of this binary storage based on a COBOL, copybook, or PLI structure that are built in IMSql. And these views allow you to access the data both in read and in write mode, as you would with any SQL table. And all data conversions are done in the background, and this relies on SQL Server schema binding to optimize for performance. And this brings me to the most value added IMSql on SQL provides the best of both worlds. Binary storage for a deterministic and risk-free data migration project and SQL access for the cloud-native modernization through these updatable views.
Thank you, Assad, for your valuable input. So yeah, indeed, having human readable and updatable views on top of the IMS data actually enables IMSql to provide integration between mainframe IMS applications and non-mainframe applications, which is something quite novel in the field that we are proud to provide. So Uli, you've had quite extensive experience with customers using cloud technologies and developing on cloud-native platforms. So I was wondering, how important do you feel data transparency is to customers? So how do you think they would value the non-transformational nature of IMSql?
Well, Markus, from a distance, one may think that modernization through transformation is just one option among many. Deciding for or against transforming programs and or data as part of the migration project may seem like a secondary issue, but it's not. It makes or breaks migration projects. At the code level, being non-transformational means that the core value of the application, namely its business logic, is preserved and does not go through a potentially disruptive process that will change its structure just for the sake of an infrastructure change. It also means that the application can keep on being maintained during the migration project. And for the data side is even more impactful. If the data must be analyzed, normalized, converted for the project, its migration becomes a project in its own right and delays and prolongs the project with a lot of risk. So for me, the non-transformational nature of IMSql is really to a risk reduction strategy that our customers can apply and then figure out what and when to modernize even beyond the capabilities of IMSql. But those tend to be longer projects that take a lot of capability and time. Therefore, the IMSql approach of being very conservative and focus on binary parity is, I personally think, a huge, a very valuable approach that is highly valuable for our customers to go and migrate, modernize to infrastructure that's modern, and then figure out how to modernize the business logic later.
So guys, thank you very much for this great discussion. If our audience wishes to know more about how to migrate IMS workloads off the mainframe and into Azure, feel free to get in touch either with Raincode or with the mainframe data modernization team at Microsoft. Bye for now.